I'm very excited to give this introductory talk and moderate this session about advances in soil health research with our colleague Stuart Grandy, talking about the microbial physiology and the linkages becoming soil organic matter, and for also listening to Dr. Dane Bell about teaching machines to screen the soil health literature, especially when that terminology is so recent. And today, I just wanted to give an introduction of terminology on soil health indicators and describe the semi-arid region where I have been working on for the past 17 years. Shown here, it is in the high plains, and it is one of the most persistent dust-producing regions in North America. And it is then a challenging region to sustain soil health. So I wanted to give that perspective to keep in mind for our meeting. As you can see here, the dust storms that we experienced recently that remind us conditions from the 1930s. And some of the challenges we have to sustain soil health begin with the soil, things that we cannot change. We have soils that are sandy, more than 60% of sand content. They also then have low organic matter, 1 or less than 1%, and they are high pH soils. Also, the climate variability that we have in the region, high wind speeds. We also have, as you can see here, in the Great Plains, generally the higher annual temperatures compared to other regions, combined with the low annual precipitation that we receive, less than 20 inches of rain in a year, even 10 more recently. And also we have then high intensity short rain events that break the soil surface. And more recently also, over the past years, we're having more extremes in the wet and the dry cycles, and more erratic variability. As you can see here, for example, this is just showing the Palmer Drought Severity Indexes, and in 2011, we had an experience, the lower Palmer Drought Severity Indexes that the soils would experience in a 100 years record. And also this was together with temperatures 2 to 3 degrees greater than usual. This was an extreme drought, and you can see here how we also then experienced over years that drought. It came out of that red zone, and in 2015, we had a record high precipitation year, and then after that, we are going into another drought. As a scientist, I feel that now we're more prepared to do research evaluating the effects of these droughts. I think in 2011, it began in Texas, 2012 went into California, and the research that I was able to do was to do soil samplings quick and compare after the drought. And we saw significant changes and detrimental changes that we could see on the soils due to that drought, but I didn't do the samplings in a way that I could compare before. I think that now we're more prepared to do this type of research. We also then, in terms of management, could see that this is where we can control things. But I mean, in this region, then cotton production is very important for the nation. We're number 1 in the nation cotton production. And then it has been done with intensive tillage operations, but we can do more on that and reduce the tillage. We also then have more the fallow periods to avoid using the water for the next year cotton production. Maybe there are things we can do on that in terms of the previous talks, talking about cover crops. And we're going into dryland production. It has been just a significant decrease over the years in the water available from the Ogallala Aquifer, one of the world's largest aquifer available in the planet. So we need to do more research to save that water. At the same time, we do research on soil conservation. So in terms of alternative managements we're increasing sorghum production as it is a more drought-tolerant crop, and we also then have more integration of livestock production, and we have a lot of land into CRP, the Conservation Reserve Program. That is the region that leads the nation in that land available under that program. However, we also know that since 2016, a lot of that land have been taken out of production. So we need to think about what we're gonna be doing and what is the best management we could do for that land. The research that I have been doing and that we are suggesting that is important for a region even like this is in terms of the microbiome. We need to concentrate on the soil biology to manipulate the soil health and resilience, especially in these type of regions. The levels of microbes found in these type of soils are lower compared to other regions. So in a way, it's even an advantage, a good research platform to look at the changes that we may see of increasing the microbial communities or changes in the microbial assemblages with any management that we decide. As it is a little bit harder to see changes in other soil properties. However, it's important to evaluate all these different indicators and establish the linkages in different soil functions. I think that there are more research and linkages that have been established in other soil functions, and we need to do our research coordinated to look at the impacts of the climate extremes, do more frequent samplings, and then also this region and similar regions like this, we should concentrate in research of what changes in the microbiome and other soil properties could be linked to increases in the soil water holding capacity. Water is becoming very precious for us in the planet. And then also our research should concentrate in the soil productivity linkages that we could establish with changes in the microbiome and other soil properties. Just an example that I wanted to give of research that I have done that is in dryland cropping systems in a very sandy soil. For the first 5 years of establishing these research plots, I evaluated then rotating with grain sorghum as possible, as it is a dryland scenario, adding a rye winter cover crop, and then also having a totally different system that would not have cotton for 5 years, a forage sorghum, a sorghum Sudan grass with rye. And this system is not a typical producer system, but it could give us a chance also to look at how much biomass we could still add to a sandy soil and what will be the changes that we will see on the microbiome. And it will give an example of the high cropping intensity that we could see here. I wanted to just show in pictures, like in the 2 droughts that we experienced during that study, in 2003 and 2006. And in dryland cropping systems like this, we will have a lot of also variability in the biomass produced. And the management history maybe that we want is not possible. The rye was not possible to establish in certain years, and we couldn't establish crops in 2006. So it's just challenging. You can see here also the cotton. You can see the grain sorghum and the forage sorghum. But it is also interesting to see that even in this scenario, we could see significant increases 2 times greater the microbial biomass carbon, an indicator that we all have been using for years, and I selected this indicator because of that. Many people know maybe values and ranges obtained in other systems, although they are so low for these soils under continuous cotton. We could see the increases once you rotate with grain sorghum, and we'll have rye. And also by 3 times, once you had that rotation of forage, sorghum, and rye without cotton for 5 years. So these changes are encouraging of being able to improve soil health in these systems. And also these changes represented increases in the fungal bacterial ratios with other indicators like FAME analysis, other sequencing trends that we observed, and also improvement in the activities of enzymes. So processes like this could also be significantly improved. And although we didn't see significant increases on the cotton yields, only on the system that wouldn't have cotton for 5 years, we were able to establish linkages on the activities of enzymes with cotton yields. As you can see here, then a significant positive linear correlation and increase that could also then be giving us indications of changes in organic matter chemistry or water that sometimes are not that easy to detect with other specific measurements for these sandy soils. This type of data also makes more sense when we put this in a national perspective. And I feel that ARS have done significant advances in soil health research over the years as an agency. We have been entering data in soil biology, many of us, through our social and scientific network. We have here Mike Lehman, Dan Manter, Kristen Beum, and many of us then that are entering this type of data with other groups that are entering like nutrient fluxes data through other social scientific networks. Jorge Delgado from Fort Collins, Colorado is leading these efforts. We also have here Doug Carlin. We're entering data in terms of soil erosion, also another important indicator for soil health. The GraceNet group entering greenhouse house emissions data. And this is with Jane Johnson, when Diane Stott was also part of ARS. I hope I'm not missing anybody. And all of these data sets makes perspective of soil health changes as they come also from similar research plots across the nation. So our group here with Dave Canable, our national program leader, Marlene Eve, the deputy administrator, what we're trying to do is to harmonize, standardize the methodology, to use similar methodology to evaluate the microbial communities and other soil biology. We're also then trying to share our resources and expertise, and also then evaluate the soil samples for as many indicators as possible. And that way, together, representing so many research plots, regions, zones, we can combine our data from multiple studies and provide trends for soil health and soil biology. And that's how we are cooperating with the Soil Health Institute, many of us, over the past 3 years, and we're very excited to continue doing this. And I'm gonna then give now the introduction for our next speaker.